Hello. Hi, people. What a good Sunday. Coming for class. Okay. Well, but a lot of people not here, huh? Ask me to do extra class, but don't come for extra class. Hiya. Okay, but never mind, guys. I'm just gonna proceed with the all the exercise lah. The PDF I share, right, is actually having three sets of questions. I will be aiming to do one set, and then the rest of the two set you all do yourself lah. So that was my initial plan. Okay. So but I see whether I can finish the whole set or not lah. Because okay, each set, right? I included all topics that you are actually having your exams. So let's say your Form 4, Chapter 2, your heating curve, cooling curve, your isotopes, okay? And then Chapter 3, you also have your calculation, your stoichiometric calculation, and then stoichiometry, I never put a lot, okay? But here, I just mainly focus on others first. Stoichiometry, I have a YouTube video for that. That's why I never do stoichiometric much here. And then Chapter 4 got Group 1, got Group 17, okay? And then anything then chapter 5 will be ionic bond and covalent bond lah. So this will be the concepts that we actually see inside here lah. So of course as I said, got three sets ma. So three set, then each set, right, I put all type of question, so it's like doing past year lah. Something like doing past year, okay? And then I actually what I do is I follow your school pass year, okay, because I got your school pass year from your ex-student lah. So what I do is I take similar question, okay, but maybe I added some other question into it also lah. So I will actually do, okay, as I said, guys, three sets I got set 3, set 4, set 5. Okay, set 1, 2 is actually your blah blah book. If you actually do your blah blah book lah. So set 3, 4, 5, and then this 3, 4, 5 will be each set got chapter 4, chapter 2, chapter 3, chapter 4, chapter 5. Okay. Did I include the answer? No, I never put answer because I want you all to come for class. After class only I put answer. Okay, ma. Okay, so I finished at least one set. Okay, then the rest of the two set I give you answer lah. Okay, can. Because I don't want you all to later you all take the answer already. You all just never come for class also never mind lah. Okay, at least come and give me some motivation. I see. Even though only got 7%, okay, good enough. 7% good enough. This is all I need on my Sunday. Okay, so guys, let's see. Let me share my screen first, okay? Okay, so guys, because it's a PDF version, right? So if you can, you print lah. If you don't have a printer, it's okay. You just go through the PDF and you write on the paper and stuff. Okay, can I? So guys, I will go through quite fast. Okay, because my plan is to do one set. As I said, three sets ma. I will do one set in within 1.5 hours or maybe 2 hours lah, maximum. Maximum 2 hours. Okay, maximum 2 hours, including explanation. So because after that I have stuff to do already, so I cannot actually delay too long. So guys, my aim probably on 4 o'clock. Okay, 4 o'clock, or if can early a bit, then okay. Because I know guys, it's a Sunday ma. Okay, so I'll do one set. The rest of the two set you do yourself, and then you all can ask me question. Okay, so let's try on the first set. Let's see. Okay, guys, my iPad is not responding to my Wi-Fi. Okay, one moment, guys. Let me off one of my stuff. Okay, so guys, so I started off with set 3, right? Can I give you all set 3, and then Okay, so guys, okay, as I said, got chapter 2, 3, 4, and 5. So technically your exam coming soon is only on focusing on 4 chapters. Chapter 1 actually not very important because it's more on the experiment, the procedure, how do you conduct an experiment and how do you write a report. So those basic apparatus and stuff, right, is your chapter 1. So I'll focusing starting on chapter 2. So I show you go for exercise. And then we're going through and guys, any question you all type it out in the chat box so don't be shy, okay? So guys, inside here you see so something like question, something like this. You see got substance A, B, C, D, E, and then got melting point, and then got boiling point. Okay, so guys, always I tell my students okay, if you see question like this, right, first thing first is to actually identify what is melting point and boiling point, like what is before melting point, what is after melting point, and what is after boiling point. So what you're gonna go something like this, okay? Let's say if I go from left to right the flow from left to right. So before melting point, obviously it's not melted yet. So it's not melted, then it was supposed to be a solid state okay, solid state like this. Okay, so before melting point is solid. Then after melting, but before boiling, so it's like melted but not boiled. So it will be a liquid form. And then after boiling point, then it will be a gas form Okay, like this So later on they say, classify your A, B, C, D, and E according to state of matter at room temperature. So guys, let you all know first room temperature usually is around 27 degrees Celsius. Okay, so more or less around this number. Okay, so what you're gonna do is you take this 27 and try to place it at this 3 different situation, see where he'll be located at. So let's say is 27 more than negative 101? Yes, right? So then you go over melting point. Is it more than negative 35? Also yes. So definitely your 27 belongs to here. So 27 more than negative 101, more than negative 35. Okay, so it'll be a gas form Then if you see B 37 is more than negative 94, but less than 65, right? So it's more than this, but less than this. So I would say that your 37 right now is in between your negative 94 and your 65. So I would say that 27 belongs to here. So I would say B is a liquid. Something like that. Then you go along with this. See, is 27 more than 17.8? Yes. Is it more than 290? No. So I'll say 27 still stay here. Okay, can Is 27 more than 97.8? I wouldn't say so. It's less than melting point. So 27 stays as solid. Okay. Then E, same thing 27 less than 801. So 27 stays as this. So what you can do, you can actually write in categorize, you can just classify so we can put something like this So solid will be your D and E, liquid will be your B and C, and gas will be your A. Okay guys, exam legit you can write like this. You can actually write this way. So but if you're scared you just write in sentence You say, oh, substance A is gas, comma, substance B and C is a liquid, comma, substance D and E is a solid. Like this also can, okay, if you're afraid but I will say like this is fine. Okay. Okay, and then state the substance that will change from liquid to solid when placed in the freezer at temperature 2 degrees Celsius. Okay, you can see So it will, they say must, okay, you have to think this way. They say will change from liquid to solid. So means initially is liquid. So who is initially liquid? B and C. But when he placed into freezer at temperature 2 degrees Celsius, he becomes solid. So he freeze So freezing point and what point is actually the same. So if you all remember, freezing point and melting point is the same. You know why? Because freezing point, melting point is technically the same temperature, but different direction. Okay. So you see, so 2 degrees Celsius. So you see, 2, is it more than your negative 94? I'll say yes. So it will still be melted. But then do you see 2 is now less than 17.8? Previously at room temperature, it's a liquid But at 2, right, I would say 2 degrees Celsius still here. Okay, still at the liquid side. But for C, 2 degrees Celsius will become at the solid side. So I will say that substance C is the one that will change from liquid to solid if you move from room temperature to a freezer at 2 degrees Celsius. Okay. So of course, going down, describe the changes that take place at the on the particles of B with relation to energy and attraction force between particles when cooled from 80 to -2. Okay, so they focus on B ma. Okay, they focus on B. So when they say cool down, okay, cool down definitely, guys. How do your particles move? How do your energy actually relate? Okay, so first of all, when you cool down something, particles move slower. Okay, but then when they move slower, right, they nearer to each other, like particles are nearer to each other, definitely their attraction force is basically stronger. Why? Because when you're nearer to your crush, stronger attraction force. Makes sense, right? Then of course you're going to talk about energy. Then what is the energy? If you move slower, then what energy reduce? Well, our kinetic energy reduce. Because moving requires kinetic energy, right? So when you cool down, you release out energy, and then you can actually have your particles to lose kinetic energy, then they move slower lah. So of course, guys, don't even need to know like what is happening here, like what state is it happening, is it from liquid to solid or solid to liquid? That doesn't matter, because they said it's cooling down. So is it cooling down? You can see that. Of course, we're going to mention the state a bit lah, because overall they say describe the changes ma. So we say that B, just now B is what? B is 80 to -2 ma. So 80 is here. 80 is a gas. Then -2 is a liquid, because -94. Okay, much lower. So it's actually a gas to liquid. Okay, gas to liquid. But what's the description? It's a cooling down relationship, right? So kinetic energy decrease, attraction force stronger. Okay, particles move slower, but their attraction becomes stronger. Okay, moving down. Yeah, Chen Ling. Anyone here know Chen Ling? Never see before a student called Chen Ling, but never mind. I hope one day I will see a student called Chen Ling. Chen Ling cleans her wall using alcohol. Chen Ling's skin feels cold when wiped with alcohol. Explain this situation. Okay, so what's the special thing about alcohol? So as you all know, alcohol, once you apply, he very fast become gas. So usually we call this what? We call this easily vaporize. So we can actually mention that alcohol evaporates when rubbed on the skin. Okay, so why you feel cold? Because when he vaporize, right? So from liquid become gas, right? Particles need energy, kind of. So where he take the energy from? From your skin. From our body temperature. So when he absorb energy from your skin, then he become gas, right? So you feel cold because you lose energy to the alcohol. Okay, so heat is absorbed from the skin by the alcohol particles, causes chilling to feel cold. So the reason why alcohol make you feel cold after you rub on it is because the alcohol absorb your energy. Then he become gas. Okay, so this will be some daily life examples lah. Then E going down, a group of students carry out an experiment to determine the melting point, okay, of your. Hey, wait, we got two Junhao. We got two Mark Junhao. Junhao, are you changing device or or someone fake your identity? Okay lah. Okay, I think it's the same lah. Okay, so you see, so you see, a student say that this is a chemical. Okay, this chemical right here, right? He got C12H24O2. Okay, it's something very complicated. It's called lauric acid. Then you can see, it says that the heating curve obtained, label the melting point. Guys, this one, I see got student made this mistake in their exam. Okay, because some school, majority of the school finish exam already. Okay, only your school haven't finished. So if you go for this, where we know is melting or boiling point, guys, you see, melting point, any point, guys, as long as any point, you have change of state, right? Either solid to liquid or liquid to gas. Change of state must be your straight line temperature, means like constant temperature. Okay, don't tell me melting point is here or melting point is here. I got student do this or straight away step him. I know, just saying. Okay, so the point is what? Okay, your melting point, boiling point, your freezing point, condensation point, any change of state point must be your constant temperature. Okay, so therefore from here, I will say that this is actually your, okay, we can say melting point. Okay, can melting point. Or if you want to be more specific, right? It's supposed to be like this. Okay, you use your ruler, okay, and then you draw a straight line. Okay, dotted straight line. Then you say this is melting point. Okay, this is a better answer lah. The one with the dotted line, straight line towards the constant temperature. My computer no sound coming out, so I use my tablet to join and listen from it and look at the bigger screen of my computer. Oh, so you use two devices, one for the sound, one for the screen. Oh, oh no. Okay, okay, okay. No worries, no worries. Okay, thanks for the effort. Thanks for the effort. Okay. Okay, now, after we go for this, right, you see, melting point, so melting point, you see, draw the arrangement particles of your lauric acid between R and S. Okay, so since they say this is melting point, we already know that QR is your melting point. So what does melting point indicate? Means before melting point is what state? Before melting point, solid state. Okay, after melting point is liquid state. Then in between melting is solid plus liquid. Okay, can so they want you to draw what? They want you to draw at RS RS means liquid How to draw liquid? You draw a box, you draw particles that attach to each other, but in random arrangement. Okay, so don't draw like tightly packed, don't draw closely packed. Okay, and don't draw particles like far away because that's gas. So you need to draw something that is there are particles that are connected, but in random arrangement. So something like this. Okay, can Don't draw like particles alone. That one very wrong. Okay, that one is for gas. Okay, and then the melting point for lauric acid is 43 degrees Celsius. Suggest a suitable method of heating lauric acid. So guys, since we know that melting point of lauric acid is 43 so what we can actually do to heat your lauric acid until it melt, I need something that can, okay, yes, we usually call this the water bath. Okay, why water bath, guys? Because usually when you want to do this experiment, right, you cannot heat your chemical directly. What we usually do is we heat water bath first, then water bath will pass the heat to your chemical. That which is in a boiling tube lah. Because we don't heat chemical directly. We never heat chemical directly one. Because if you heat chemical directly, your chemical will be like it'll be unfair. The bottom part hot first, the top part hot. It's still cold. So it's like the heat is not uniform. So therefore we use a water bath to give you uniform heating, or we call it the even heating. Okay, so since they say 43, your water bath is suitable. Why? Because water bath maximum can go until 100 So 43 easy, sui, okay, for your water bath. To reach 43 But if you have something that is more than 100, okay, let's other examples lah. The melting point is 130. Then you can use water already, because water cannot give you 130 degrees Celsius So then you're gonna use oil bath or maybe sand bath, up to you lah. Okay, so of course, oil bath is the more common one. So draw a label diagram to show the setup apparatus for the method suggested. Guys, I know most of the question you all do is they give you diagram, then they ask you question. But sometimes, if your teacher wants you to be more like make your life harder, they want you to draw. So guys, how do you imagine? You're gonna have a beaker, water bath, a beaker with water, and then you have a boiling tube in the middle, and then thermometer inside the boiling tube, and then with your chemicals, and then at the bottom you have a tripod stand with a Bunsen burner. But don't have to draw Bunsen burner, okay guys? Just draw an arrow and then just point it up, label heat. Okay, no need to draw Bunsen burner So we can do something like this. Okay, and don't forget your boiling tube is actually held by your retort stand. You must also draw the retort stand. If not, how do you hold this? If not, your chemical gonna be like slanted and lie on the beaker. So no. Okay, your boiling tube must be held by a retort stand because your bottom of your boiling tube cannot touch the beaker. Okay, because if your bottom touch the beaker, the heat transfer very fast. If the heat transfer very fast, again your chemical heated up is not even, it's not uniform, so it's incorrect again. Okay, so guys, okay, try to imagine heating and heat experiment of heating. It will be on this arrangement. Okay, guys, so give you guys like 1 minute to draft it out yourself as fast as possible. Okay, guys, done So guys, never mind lah. So how many marks for drawing? Usually 2 marks. Drawing usually 2 marks. Hey, don't look down on these 2 marks. Hey. What if they got many drawing in exam? Huh? Hey. Minus 2 marks for me. Wait. Hey, now you see you draw one time already ma. Exam if they ask you, then you can draw lah. As for drawing, don't be too ugly. Okay. So going down. Yeah. So this one will be the next type of question for chapter 2. Okay. After heating and cooling curve, we have isotopes. So we have 2 isotopes here, phosphorus 31 and phosphorus 32. Okay, so there will be something like this, 31 and 32. Define isotope, guys. Please memorize this definition. Exactly every word. Okay, because a lot of students, they just memorize the simple word, right? Then they never write the full sentence. Teacher don't give you mark. What is the full definition for isotopes? It must be the atoms of the same element. Okay, must be these few words. Atoms of the same element with the same proton number but different nuclear number. Okay, but if you don't use this word, you say, teacher, can I change to same number of proton? Can. But then at the back, you must change it to different number of neutron. Okay. It can be in package. Okay. If you want to use proton number, you go with nuclear number at the back. If you want to use number of proton, you go with number of neutron at the back. Okay. Please remember this. Must memorize the full sentence, every word. Okay. No other choice. Okay, because a lot of people just memorize, oh teacher, I know, same proton number, then different nuclear number. Means you only write the sentence at the back. Wrong. Okay. Yeah. Okay, then state one similarity and one differences between the 2 isotopes. So guys, as we see from here, what is a similarity? Same proton number ma. So same proton number give you what? Same proton number give you the same, we call it the same chemical properties because they got same valence electron and everything lah. Then because different nuclear number is like the mass of an atom. So the mass, like we call it the atomic mass is different, the density is different, the physical property is different. So there are many answers here. So you can see that both isotopes have same proton number, number of neutron or number of electron. Again, these two, you choose one. Then isotopes have different number of neutron or different nuclear number. Up to you. Okay. So you're gonna be like, teacher, then if you know how to write definition, I mean, we also know how to write the similarity and differences, right? Definitely. But we are putting here because we combine many possible questions into one question, so that you all actually face different kind of question at the same time. Okay, then for C, right, they say phosphorus forms simple molecule which have relative molecular mass of 124. Suggest the formula of phosphorus molecule. So guys, what happened here? What is the relative molecular mass of one? What's the meaning of relative molecular mass? So if we see the word, I mean, we know that relative mass is basically the mass of the chemical but what's molecular mass? Molecular mass means that it don't exist alone. Like if I tell you hydrogen molecule is like H2, right? Like oxygen molecule, it's O2. Oxygen gas, oxygen molecule is O2 But if I tell you like sodium atom that is just Na. So no multiple Na together, just Na itself. So right now they say phosphorus, which is this P, they form simple molecule, but this molecule not necessarily is two, but it's always two because we always talk about gas. Like hydrogen gas is H2, oxygen gas O2, nitrogen gas is N2, chlorine gas Cl2, but phosphorus is not a gas, but then it's a molecule. So how am I supposed to know the quantity of your phosphorus so that he actually becomes a molecule? So what you're gonna do? You take the molecular mass, which is a total mass, okay, equals to your phosphorus unknown first. So what's the meaning of that? So you see, okay, first of all, okay, relative molecular mass means like the total mass of how many P total up together But if you look at your P, your P got how many type? Your P got phosphorus 31 or phosphorus 32, right? So this 31 and 32, guys, this is actually the mass of what we actually have the mass of your phosphorus. So what we know, okay, see the step one, you see you know the relative molecular mass is 124 okay. So what's the next thing to do is to find out your P, because we don't know the P how much So I put a P can be any unknown. Okay, I put Px or maybe Pn like this. Okay, then I take this number equal to your 124. Okay, then I put in your 31. So why 31? Because do you see we got P31? P31. So P31 put in, and you actually try to find the n, you find your n equals to 4. Okay, and what does this n equals to 4 means? So if you see that, we can say the formula is P4. Just like oxygen is O2, like hydrogen is H2. But P is not 2, P is 4. So it means that when P exists as naturally in nature, he naturally is actually a P4, not P2, not P3, is P4. And how do we know this? By using the total mass and find out the P that we actually have from here, the N. To be specific is the N. Okay, because P we know is 31 or 32. Okay, some of you say, teacher, can I use the 32? Also can. You use 31, then you get the N for 31. You use the N for 32, okay, you get the N for 32 so lah. So also can one, okay. So guys, so overall, from here you can actually get a whole number. I would say 31 is the more suitable one. Phosphorus 31 lah. So from here, you put in your 31, and you put in your N. Okay, you look for the N, then you substitute your N equals to 4 back to your P, N, then you get a P4. So this is like a reverse way to calculate that. Oh, by knowing the total mass, I can know the formula of this chemical. Okay, now state two different physical properties of 31 and 32. Guys, what's physical properties? Physical properties, guys, must be your brain. When they ask you about physical properties, must come out this few information. Like what? Like density, electrical conductivity, melting point, boiling point. All this is your physical property. But as we know, 31 and 32 is the nuclear number, right? Nuclear number is also the mass. So if the mass change, density change, your what do we say? Just like I say, I have different answers. Melting point, boiling point, and then the mass change, the density change. Okay, so either from these two, choose one. I mean, choose two. Because they say state two different physical property. Then chemical properties is basically the experimental result. Means that you try to do burning, try to do throw in water, then you get chemical properties. Okay, so physical properties stick yourself to melting point, boiling point, density, mass, electrical conductivity, solubility in water. These are the stuff that we actually have for your physical properties. Okay, so physical property is melting point, boiling point, density, and then got atomic mass. According to this question, we got atomic mass. Okay, and then got what? Got electrical conductivity. And then got solubility. So these are all consider your physical property. Okay, and then going down, will the two isotope of phosphorus react the same way? Guys, when I say react the same way, it's basically asking you about chemical properties. Okay, because reaction consider chemical reaction so chemical properties lah. So chemical properties as you can see from here, they ask you, will these two react the same way So do they react the same way? And what does chemical properties depends on? It depends on the valence electron. So if proton no change, then electron also no change. If electron no change, then valence electron no change. If valence electron no change, chemical properties no change. So you see our answer here? Yes. Okay, the answer is yes, because they have the same number of valence electron, they have same chemical properties. So when they got same chemical properties, they react the same way. Okay. So guys, reactivity, reaction, it's all dependent on your chemical, on your valence electron. Okay, guys, remember chemical property very, very dependent on valence electron. Okay, instead, one use of isotope of phosphorus, guys. This one is testing on the memorization, guys. Have you memorized your isotope function? We got uranium 234, 235, and then we got carbon 14, and then we got sodium 24, we got like cobalt 60. All these guys must memorize. Okay, so one of it is phosphorus 32. Okay, so for 32 is for fertilizer. Okay, yes, it's for fertilizer, but to be exact, is for you to study the uptake of fertilizer. Means that it's not meant for like actual fertilizer in daily life. It's meant for you to study whether the fertilizer is functional or not. So you can see, so to see for here too, used in fertilizer to study the plant metabolism. So you have to mention the word that for study, okay, it's for study purposes. It's not for you to like sell it to other people and then people get cancer from here. No, lah. Okay, so the point is, it is fertilizer usage, but you must mention it's for study purposes. Okay. And G, guys, calculation, a lot of exam actually ask this question. So if this one come out in exam, please know how to do it. So how do we do calculation for relative atomic mass? If you got two or maybe three isotopes, you just take percentage multiply mass, percentage multiply mass, plus together, total up, divide 100. Okay, can but not necessarily always 100 one. You know why? Because sometimes the number here they give is not percentage. Maybe total up is like 98.9 or maybe 103. So to be exact, not always divide 100 lah. Unless it's percentage. If it's percentage, then yes, always 100% one ma. But if it's not percentage, it's like they say ratio. Then you must be more careful on that lah. But I would say most of the question is divide 100. So how do you do? So relative atomic mass will be percentage multiply mass plus percentage multiply mass divide 100. Okay, so guys, you do a maths lah. You all press your calculator. You're supposed to get this one, a 10.8. This is what I get from. This is what my answer showing me lah, guys. I lazy to use calculator lah. Okay, 10.8. Okay, very easy calculation. Hopefully this one you can score. Then going down, they say Cl35, there's a chlorine 35, can also represented as Cl35 lah. Okay, so there's a different ways of writing. The element has another isotope represented as Cl37. Calculate the relative atomic mass if the natural abundance is 75% and 25% respectively. Oh, guys, same. Okay, so relative atomic mass is percentage multiply mass. Okay, guys, so 35 with 75, 37 with 25. Okay, you go follow by sequence. They say Cl35 and Cl37 are 75% and 25% respectively. So we go with the flow. So then same thing plus percentage multiply your mass divide 100. Okay, so guys, you do a calculation, you get similar 35.5. Okay, guys, I'm not gonna stay long because as I said, we are here just to compile all the things you all learned before to refresh your memory. Okay, so we try not to waste time on writing many stuff because I know you all, some of you don't never print okay? If you never print, then a bit hard to write so I'll post the answer later, guys. Don't worry. After class, I'll post answer. Okay, can So going down, okay, guys, this one is empirical formula. It's more on this chemical called the oxide D. Okay, you sometimes in exam, right, they never give you the specific name of the chemical. Can be different chemical, can be magnesium, can be copper oxide. Okay, but of course, guys, this diagram line is actually outdated. Okay, because this question is actually a old version question Nowadays, they use the new version. The new version is supposed to be something like, let me show you yeah, I never put the normal the copper oxide question. Guys, remember there's something like this one. Got two test tube, okay, test tube, and then got like a tube connected here. Like this. And then there's a block, and then there's a spirit lamp, and then there's usually here is a copper oxide. Okay, so this is the latest version of the of this arrangement. Okay, but the theory, guys, is the same. You know why theory is the same? Because at here usually is HCl plus zinc. So do you see hydrochloric acid plus zinc? Do you see same? But nowadays they don't use they don't use this chemical X anymore. They just straight away HCl plus zinc. Okay, you do the reaction. You kick off the H, becomes zinc chloride, and also hydrogen gas. Guys, sorry, my cat suddenly scratching my sofa. Moji, don't scratch the sofa. Shh. Sorry, sorry. You scratch the sofa, I scratch you. Moji, come down. Shh. Okay. Okay, so yeah. So from here you see guys, what's the point of like producing the H2 right here? Is when you actually produces the H2, the hydrogen gas comes up, okay, the H2 comes into here, right? Then the CuO, he will react with the H2. Then what happened? Now it's the turn for the H2 to kick off the Cu, snatch the O, becomes Cu and H2O. So the actual reaction actually happens here. The main reaction happens on the top. Then what is the purpose of this right hand side test tube? Is basically just a process meant to produce H2 hydrogen gas. So it means guys, even if you see this picture, because I sometimes teacher don't know why they still want to use the old diagram. So just in case, okay, I give you the new diagram. I also give you the old diagram. So here it's the same thing. Okay, the main purpose of here is to produce H2. Okay, and then we don't use chemical X anymore because actually chemical X is for you to dry it off, becomes dry H2. Because sometimes we scared that the H2 comes with a little bit water vapor. So the water vapor might affect your mass, which is the result lah. So we try to not to do that. So we try to dry it off and then we get a dry H2. Then only we go into your oxide D. So your oxide D will be like D oxide with H2. Similar concept means your H will snatch the O, becomes H2O, and then the D becomes alone. Okay, try to imagine D right now is your copper. Okay, imagine a D right now is a copper. Same concept. Okay, so don't get confused even though in exam they give you like unknown, maybe they give you X, they give you A. Okay, so as long you see the zinc plus hydrochloric acid must be about the empirical formula of copper oxide. Guys, because I give you a big picture. Empirical formula only got two. Okay, only got two types of experiment. Empirical formula, first type is the magnesium oxide, guys, the MgO, the open, close, and the crucible one. Okay, then the second type of empirical formula is this one. The copper oxide one. So you got two type, magnesium oxide and copper oxide. Two type of empirical formula experiment. But of course, they can do, if you ask you to do empirical formula calculation for other chemical, it's possible lah, because calculation is always the table ma. Okay, but if you're focusing on empirical formula experiment, it only got two, the MgO and the bow and crucible lead one, okay, and the other one is this one. Okay, so the experiment empirical formula only got two. Okay, so of course for here, A is something that you all actually don't have to actually go through because it's something that is quite the old question version. So this one you all can ignore. You all can ignore. Okay, so what you can do is here, calculate the mass of metal D and oxygen. So how you get metal D mass? So to get metal D, let's say if I label 1, 2, and 3. So what you're gonna do? You're gonna take your okay, yeah, to get metal D, I will take 3 minus 1. Okay, 3 minus 1, but to get oxygen, I will take 2 minus 3. Excuse me. Okay, guys, so with the 3 minus 1 and 2 minus 3, you're supposed to get the mass of D and the mass of oxygen. So once you get the mass, I believe you all can do your own empirical formula calculation, right? Guys, be careful because in exam, they won't give you table. You have to draw the table yourself. As long they say calculate empirical formula, then draw table. Okay, so what we have for here is we have oxide D, right? So technically you have a metal D and then you have this oxygen. And then you have the mass for D and only for the O, so I can put it in, okay? So according to the previous calculation, you can put in the mass of your D and the mass of your O. Then what do you do next, guys? When they give you mass, and then do you see they give you relative atomic mass, which is molar mass, correct? What's the formula for number of mole? Is mass over molar mass. So you put in your calculation, mass over molar mass, mass over molar mass. Then if you get the same number, guys, you're supposed to get the same number. You know why? Because in the two experiments I mentioned just now, the magnesium oxide and the copper oxide, both of these experiments always give you ratio 1:1. So in exam, if you really suddenly you get some weird numbers, like you get the ratio is not 1:1, means something wrong with your calculation. Okay, so ratio of these two experiments must be always 1:1. So 0.1 and 0.1. So the ratio is 1:1, simplest ratio also 1:1. And what will be the final empirical formula? 1D and 1O. I will say is D oxide. Just DO. Okay, DO and guys, D is what? D I will say high chance is copper lah. Okay, can okay, because even though I don't know who is D for now, but this experiment mainly focusing on copper oxide. Okay, the CuO. Okay, then going down, explain why process of cooling, weighing, and heating is repeated a few times until a constant mass is obtained. So guys, as we say, this experiment, the only result is the mass square knot. So how you know when your experiment is done? When do you know your experiment is like finished? You actually don't know one. By your eyes, naked eyes, you cannot see one. I say, hey, I feel like it's done. No, you can't use feeling. So what you have to do, your result is a mass. So you have to actually heat, cool, and weigh heat, cool, and weigh to you get the reading continuously, like we repeat many times. If your mass is still like changing, either it's increasing or decreasing, means it's not done yet. You have to keep doing your experiment, heating, cooling, weighing, heating, cooling, weighing, until every time you repeat, your mass is not going up or not going down, it's becoming a constant mass, then only you know your experiment is done. Okay, even though you all do in school the crucible and heat one, your teacher don't do this the teacher just say burn, just heat until maybe like 10 minutes or 15 minutes, then confirm finish. That is because the teacher know after 10 minutes, after 15 minutes, confirm finish one. But in real life, the actual way to do this experiment must heat, cool, weigh, heat, cool, and weigh, heat, cool, and weigh, and until the mass not go up, don't go down, then only your reaction is done. Okay, so in the exam, you cannot assume or use feeling, use 15 minutes. No. Okay, this you can say, okay, to ensure all the oxide D has changed to metal D by repeating your cooling, heating, cooling, and weighing process repeated a few times. Okay, and then Daniel repeats the experiment by replacing oxide D with zinc oxide. Actually, why Daniel cannot use the same method to determine the empirical formula of zinc oxide? So guys, the reason why we have two different experiments is because both experiments, right, they cannot be actually used for each other. The reason why here only works on copper oxide because H is more reactive than copper, but definitely less reactive than zinc. So we can say that will be zinc is more reactive than hydrogen, or you can say zinc oxide cannot be reduced by hydrogen gas. So technically, is zinc more handsome than your hydrogen. So hydrogen cannot snatch his girlfriend. So this will be the concept lah. But if you try to do the magnesium oxide experiment, you try to do with copper, also cannot, because copper is less reactive, right? Magnesium oxide, the experiment is directly heating the metal piece, the piece of metal, with oxygen, while copper usually don't react with oxygen that fast. So that's why they are not suitable for each other. Okay, so this one, you have to ensure these two reactions, you have to be very clear. Then why is hydrogen gas passed through the combustion tube for a few minutes before heating? This one, even in the new setup, okay, the new diagram, they always ask you one. They like to ask you before you start your reaction, you must flow your H2, your hydrogen gas, for a few minutes before starting, and also keep it flowing even if you done experiment, keep it flowing until you stop. I mean, after 5 minutes. So there are two type of question lah. Before, why must flow for 5 minutes? After, why must flow for 5 minutes? So there are different reasons for that. So before you start your reaction, you flow 5 minutes is because to remove all the air, correct? Ensure all air in combustion tube is removed. Because if you don't do this, what happened? Oxygen in your normal air and the hydrogen that you just produced, H2 and O2, you heat explosion. Yeah, so this one is something dangerous lah. Then if they ask you, let's see, okay, they never ask you the other one, never mind. Okay, then they ask you to write the chemical equation. So chemical equation will be your D oxide, okay? And we cannot write copper oxide, guys, even though I know it's copper, but cannot write copper if the question never tell you. Okay, be careful on this. If they give you unknown, you use as unknown. But the concept apply the same as copper oxide. So plus your hydrogen gas becomes H2O plus D alone. So that is finish 1 mark. Okay, then G and H, right, guys? It's a old question for the old diagram. The new picture don't have it anymore. Okay, but I guess in my answer later I still give you lah. Just in case your teacher has gone crazy, they give you old version diagram. So I don't know lah. Okay, so I give you all these questions just in case. Okay, but I would say recently teacher getting more advanced. Okay, teacher also updating themselves. Now recently they don't ask the old diagram anymore. But as a precaution, just in case. Okay, so guys, this one G and H I don't do lah. Just like the A I never do, so because all this is the old diagram. The answer later on still be provided. Okay, just in case you are curious about that. Okay, the rest, guys, focus on the rest. It's more than enough in your exam. Okay, if okay, chapter 4, group 1. Okay, guys, chapter 4 got what? Group 1, group 17, group 18, period 3, transition element, got 5 topics. Okay, so I try to do whatever we have here. So we have element PQRST, proton number given, neutron number given. They say T burns in air to form an oxide. Okay, T is like 19 ma. Okay, so you've got 19 proton number, means got 19 electron number also lah. Okay, so you've got 19, what's the arrangement? So be 2.8.8.1. 19 ma, guys, you see the arrangement. Okay, if I try to write out the arrangement, 2, then 2.7, 2.8.1, 2.8.7. So all this is the arrangement of your element PQRST. So since we talk about like 19 is like 281, right? Guys, wanna guess who is this? Remember, guys, do you see it ends with 1? If it ends with 1, what group is this? This guy belongs to group 1. Okay, can And what is the element in group 1? I hope your teacher will give you periodic table lah. But if the teacher never give you, like, you cannot do anything also. What's the element in group 1? We have lithium, sodium, potassium. These 3 is your maximum you learn, okay? But what's the arrangement for lithium, sodium, potassium? It's 2.1, 2.8.1, 2.8.8.1. So I will say, I found that my T is actually my potassium, my K. But don't write K, guys. Later, anything, don't write K. Use T as your element symbol. Okay, still remain T as element symbol. But what they really want is write an equation for burning with air. So what is the equation for burning with air? So if you try to write the equation directly using potassium first, it will be K burning with air. Guys, what's the burning gas that we need? Every time when we burn, right, we requires oxygen, correct? So oxygen, then you becomes what? Guys, if K and O2 combines, is it just KO2? Do you think chemistry works so easy? Do you think chemistry is just like maths 1 plus 1 equals to 2? 1 plus 2 equals to 3? No, okay? So what is forming at the back? Because guys, before they combine, they are atom and molecules, right? But when they combine, do you see it's a metal and non-metal? It's a metal, non-metal, ionic bond. So if it's ionic bond, remember the ion. What are the charge of K? It's K plus. What's the charge of O? It's O2 minus. Guys, all these got memorized or not? I don't think so, okay? So if you never memorize, must actually go with this memorization. So if K plus and O2 minus, you exchange the number, you get K2O. Then of course, you have the balance equation. So with 2K2O and 4K. Okay. So guys, that's why we learn balance equation. If chemistry is so easy, everything plus together, you form your equation, your chemical at the back, just plus together. Why do we even need to learn balance equation? Right now. So the reason why we learn balance equation is because the chemical that you form at the back usually is totally different. The quantity also different. So that's why we need, after you write out the normal equation, then only you balance equation. Balance equation is always after writing out equation already. The last thing to do is always balance equation. So if you can write out this thing, then you can modify your K to your T. So you can see 4T plus O2 becomes 2T2O. Instead of K2O and 4K, now you have T. Okay, guys, can burning with oxygen, this is group 1 burning with oxygen. Then they say this oxide is then dissolved in water to write a chemical equation. Okay, guys, if you want to dissolve in water, I'm going to take your K2O plus water. So what do you get, guys? So if you remember, H2O plus your metal oxide, this K2O, it becomes one thing only. And what is that one thing? KOH. Then balance equation. Okay, so you're gonna get something like this. See, T2O plus H2O, you get 2TOH. Okay, guys, all this equation, remember? Hopefully you all still remember lah, because I know you all been through bio, been through physics. Okay, I know your confidence right now is very low. Okay, confidence level very low. But if you see, same. Okay, one. Are you all done with MX? When's MX? MS finish exam or not? Okay. Is it tomorrow? Over already? Okay. Okay lah, the hardest thing over already ma. Can lah. Chemistry so easy. Okay, then for B, pick an element that have the same group as element T, guys. Same group is group 1 ma. So who also group 1? I will say is your element R, because they have the same valence electron. So we can say from here, R. Okay, guys, be careful. Must put the word element R. Okay, I don't know why some teacher just very specific on this. Okay, they say, cannot, must write element R. Okay, so to avoid that error, okay, let's always be more specific lah. So both elements have this have one valence electron. Okay, and between these two elements, which is more reactive, guys? Here comes our reactivity. So in group 1, how do we define reactivity? So you're gonna ask yourself, group 1 elements, right? Do they want to lose electron or gain electron? If you think about it, 2.8.1, 2.8.8.1. So both of them having one electron, right? So both of them try to lose electron and become stable. And if you want to lose electron, how do we define more reactive? Look at the one that is easier to lose electron. How do I define easier to lose electron? Okay, R got 3 shell, but T got 4 shell. So if I want to lose the last electron, obviously 4 shell is easier. Why? Because 4 shell, the electron at the nucleus far away, right? Further away. So if the distance further away, if you and your girlfriend further away, your force is weak. So when your force is weak, easier to break up. Okay. But of course, guys, usually this question is 4 to 5 marks. You're going to be more specific on that. So sentence number 1, you talk about the atomic size. Talk about the shell. Shell size bigger, okay? If size bigger, distance further. If distance further, force is weaker. If force is weaker, it's easier to lose electron. But guys, all this is just keyword. You must bina ayat. So we're gonna get something like this. So element T more reactive than R. Why? Atomic radius of T bigger than R. And then valence electron further away from nucleus of atom T. So T got like further away electron. So then atom T easier to release one valence electron to achieve stable octet electron arrangement. So see, do you see this whole sentence is basically what I mentioned just now, but in a better and in a more detailed explanation. So guys, reactivity for group number 1 is very common. Down, which element exists as monoatomic? Guys, we have two types, right? We have diatomic and monoatomic. Diatomic is basically like the group 16 and group 17, which is your gases. like oxygen gas, chlorine gas, nitrogen gas, hydrogen gas. All this is diatomic. But who is the only group that can be monatomic? Usually it's your group number 18. Okay, so you say, so is there any group number 18 here? Okay, anyone ends with 8? No, right? But there is an element in group 18, which is P. Why P? Even though it's a 2, but it's in group 18. Because group 18, yes, we know group 18 ends with 8, right? Except for first element. Why? Because first element is first shell. First shell maximum only can have 2 ma. First shell how to get 8? So 2 is already the maximum of a first shell. So I will say 2 is also like element P, the 2 electron, is also considered your group 18 first element. So because this element has achieved duplet electron arrangement. So for element P having a 2 in first shell, we call it duplet. For octet, is 2.8, 2.8.8, and rest. And then state the group and period for element S. Guys, these are also very common in exam. So when they ask for group and period, is basically checking your valence electron and also what's your number of shell. So you can see element S is where? Element S is ending with 7, so group 17. And then how many shells? 3 shells, so period 3. Okay, including your explanation now, guys. Oh, I think here they never asked you to explain. So we just say, or they ask you, okay, guys, usually exam always come with explanation lah. So we say that group 17 because got 7 valence electron, period 3, 3 shells filled with electrons. Okay, it depends on marks lah. If the marks of this question is like 2 marks, then no need to explain. But if the mark of this question is like 3 marks, 4 marks, then 5 marks, then you must explain lah. Okay, and explain why element S has low melting and boiling point, guys. Element S is where? Element S is this one, 287 ma. So 287, right? As I said, it's a group 17 element, group 17, So it will be a non-metal. So group 17, non-metal. Non-metal means what bond? Guys, non-metal means covalent bond. But as I said, guys, if you remember covalent, do we actually break covalent to melt and boil your non-metal? Just like, guys, you see, let's say if I got hydrogen, this is a hydrogen. If I want to melt or boil your hydrogen, do we break this covalent? No, we actually have what? So in between another hydrogen like this, okay? So we don't actually break the covalent. What we break is we break the weak forces in between your molecule. So what usually we call this? We call this the van der Waals. This is weak. And because this is weak, easily boil, easily melt, they easily become gas. Okay? So we are not having a weak covalent bond, guys. We don't have weak covalent bond. What we only have is weak van der Waals force. So when you can say from here, so S exists as diatomic, they are held by weak van der Waals force of attraction. A little heat energy is sufficient to overcome this weak force. Therefore, it has low melting point and boiling point. Okay? Don't ever write weak covalent. Please, weak covalent is a very, very wrong term. What you have is weak van der Waals. Okay, and this van der Waals force, right? Sometimes they can say this, we call this the intermolecular force, or sometimes you see a lot longer word, forces of attraction between molecule. So there are multiple ways of calling this lah, but van der Waals is the easiest and the common way to use. Okay, and write an equation for R and S. Okay, as we know, S is what? S is your 287 ma. R is what? 281. Okay, guys. Here, this question are also very common because of what you all do is R plus S. You form RS. Guys, wanna guess what's the error? As I said, guys, chemistry not so easy one. Chemistry equation, you think really 1 plus 1 equals to 2? So what is the error right here? Number 1, do you realize S is group 17? And group 17 always exists as what? Always exists as diatomic. Means that even though you do not know S, is it chlorine, is it bromine, or is it fluorine, it doesn't matter. S must be S2. A lot of students forgot to put a 2 for this. Okay, then you're going to be like, teacher, how we know? How we know? Because group 17 diatomic. Group 17 diatomic then must be having a 2 in the equation. Okay, and one problem is how you know it's RS. Why not R2S? Why not R3S? Why not RS2? Why not RS3? So this comes into play where? Do you see R is metal? S is non-metal again? Metal plus non-metal is what? Ionic bond. So ionic bond, check the ion. So you see, do you see R 2.8.1? So if he lose the electron, he becomes R plus. Then your S will gain the electron, he will gain electron, become S minus. So do you see it's R plus and S minus? RS is correct. So RS is here correct lah. Okay, so this RS here is correct. But of course, in exam, they might not like this one. They might ask you, or maybe they give you, R is 2.8.2, then your R is 2 plus. Then you're gonna get RS2. So it all depends on the ion that you form on that question. Okay, so not always plus together is just RS like this. Okay, not they say that in future you see A and B, AB. Okay, this is not maths, this is chemistry. You have to identify what ions they form by losing or gaining the electron. So of course, back to here. So until here is all correct because R can be alone. Why R can be alone? Because R is a metal. Metal can be stable by atom itself, but S is non-metal. Non-metal must have pair, which is S2. Of course, the last thing to do is the balance equation. So 2RS, 2R. Then this is your final answer. Okay guys, in exam, when I ask to write equation, think twice. Think about identify who is it. Is it a metal? Is it a non-metal? And if it's a metal, what is it? If it's a non-metal, what comes with the 2? And then what do they form at the back? Check the number of charge after they lose and gain electron. Okay, going down, going down, Okay, so now going down, this is group 17. This one was group 1, okay? So now we focus a bit on group 17, So group 17 is basically your fluorine, your chlorine, your bromine, okay? So then now we actually pump this chlorine gas into 2 different chemical. One is water, one is sodium hydroxide, okay? Guys, before I start the reaction, let us try to construct the equation first. What's the reaction? What's the equation for chlorine gas with water? So if you remember, chlorine gas is Cl2, with water is H2O. I bet you all forgot this thing. You know why? How you form chlorine with water? What chemical do you form? If you remember, I told you, water inside is actually H and OH. Correct or not? So, H will combine with one of the Cl, become HCl. But then do you see you left with OH? Also combine with another Cl because you got 2 Cl. Each of it take 1 Cl lah. So you have HOCl. If you remember, this is your acid, this is your bleaching agent. Anything start with HO is your bleaching agent. Okay, so this will be your equation for chlorine with water. Then if you try the next one, chlorine with sodium hydroxide. What is sodium hydroxide? If you still cannot remember until now, start to memorize your chemical. So NaCl. Okay, so what happened here? Sorry, guys, why NaCl? My bad, my bad. NaOH. Okay, how do you memorize this equation? I told all my students the easiest way to memorize this equation is to put a 2 right here first. Then what happened next? You think about having you have 2 NaOH, okay? So you take out water, take out H2O, then what is left? NaO and Na, both of them combine with the 2Cl. So one is NaOCl, one is NaCl. Okay, so this will be the equation that you can get from chlorine with water and chlorine with sodium hydroxide. Okay, state one observation that can be seen for both of the reactions that occur in beaker A and B. So guys, do you realize no matter which one, they actually have blue litmus paper? Okay, so of course, what you can actually see, since I here beaker A, blue litmus paper turn red, then bleach to white. Okay, but for B, right, guys, B, no acid, there's no HCl, but then still got the NaOCl. You see that? Still got the OCl, right? So that one also blue straight away bleach to white, just no red color. Because if you want red, right, you need the HCl. But for the other one, the beaker B, no HCl, only got NaOCl. So only the bleaching properties. Okay, and then write the chemical equation. I guess I already done this for you lah. So now you're gonna get something like this. Cl2 plus H2O, you get HCl plus HOCl, and then the rest is the same as the right side lah. Okay, but guys, some of you might say, teacher, the double arrow is important. I would say in your current situation, right, your double arrow doesn't matter first. Okay, just go with a one direction arrow is fine. No need to think too much about the double arrow. For now lah, for now lah. Future, you might need to be careful on this. Okay, now, state one precaution that must be taken while carrying out the experiment. So guys, when you all do this, right, be careful of one thing, because this thing, when he touch water, he becomes acid. So make sure you actually don't breathe in this. So what do? Don't breathe while doing the experiment. No lah. Okay. So the point is, you must do at a certain certain area that has exhaust fan. So usually we call that the fume chamber. Can don't say don't breathe. Okay, then if the experiment is repeated using bromine gas to replace chlorine gas, compare the solubility of the two gases in water. So guys, if you see, bromine gas, now you change from chlorine, you change it to bromine. So talking about solubility is the same as reactivity. So talking about reactivity, how do we understand? So I told you, group 1, right, going down, getting more reactive. Group 17, terbalik, going down, get less reactive. Why? Because group 17, they are trying to gain electron. While they go down, the more shell is harder to gain electron. So use the same concept lah. So chlorine gas is more soluble in water compared to bromine. Okay, so link to reactivity lah. Okay, link to reactivity. Okay, so one thing, group 1 going down more reactive, while group 17 is going down less reactive. Okay, have this as a basic general concept. Okay, then your liquid bromine, okay, we warm it up and then goes to a iron wool, guys. You see, one question asks you all 3 reactions in your group 17. You see how crazy it is? Because every group, right, we learn 3 experiments. Like group 1, we have throw into water, burn with oxygen, burn with chlorine. Group 17 also got 3 experiments. Throw in, dissolve in water, dissolve in sodium hydroxide, which is the first 2 already got from here. And then the last one is burn with iron wool. One question gives you all 3 experiments. Yeah. So now from here you see, say to precaution must be carried out during the experiment. So guys, again, these are all very toxic, very poisonous. Okay. So what we have to do, make sure all connections are tight and carry out it in fume chamber. Iron wool to prevent oxygen. No, no, no. Iron wool is for you to react with the bromine. Because you see, do you see we warm it up? So if you warm it up, the liquid bromine, right? It's supposed to be just bromine gas coming through. So bromine gas coming through, react with the iron wool, it forms into iron 3 bromide, FeBr3. If you warm it, if you have a chlorine gas comes in, you get a FeCl3. Okay. It's actually a burning process lah. Not burning, sorry. Your bromine, chlorine go in, and then you see how fast they react. Okay, and describe and write the chemical equation between bromine and iron wool. So from here, I will say something like this. You see, so bromine gas react with iron wool to produce iron 3 bromide, which is I gave you the equation here. Then bromine gas react with sodium hydroxide to produce sodium bromide, sodium bromate 1, and water. So this is the equation. So guys, do you see this equation very similar to the one on the top? Okay, on top is Cl2 ma. Here I just change it to Br2. Okay, so this will be your description on your equation and on what you form. Okay, the reaction with iron wool actually got also got show you reactivity one. Okay, let me show you. Let me wait because maybe some of you might still be thinking, teacher, what is the reactivity? Let me show you. So for group 17 is then this one. Okay, if your chlorine, bromine, iodine, okay, if you heat it with iron wool, ignites rapidly, glows moderately fast, glows slowly, and then you form a brown solid, which is the iron 3, iron 3, iron 3 at the back. So this is the reaction with iron wool. When you see it, the flames shows you the reactivity. Okay. Guys, all these observation must memorize. Okay, so after group 1, after group 17, then we got, of course, period 3 and transition element. Okay, so first arrange these elements in ascending order of electropositivity. So guys, what is electropositivity? So it's about tendency to gain, sorry, terbalik, guys, tendency to lose electron. Be careful on this, tendency to lose electron. If it's electron negativity, it's tendency to gain electron. Okay, how to know whether to lose electron? You see, 2.8.2, 2.8.3, and 2.8.4. So guys, which one actually gives you higher tendency to lose electron? Which is the one that is the smaller valence electron. So we say that ascending order means from the least electropositivity to the most electropositivity. Or we say go from right to left. So silicon, and then aluminium, and then your magnesium. Okay, why? Because if you think about it, 2.8.3 and 2.8.2, who is easier to lose electron? So I would say 2, because 2 is it nearer to 2.8 compared to 2.8.3. So this will be the electropositivity. So if at the terbalik, if they ask you arrange in ascending order of electronegativity, then you go from left to right. Okay, so this will be electropositivity, so right to left, electronegativity will be left to right. Classify this element into metal and metalloid. So guys, who is metal? I will say magnesium, aluminium is metal lah. Then metalloid is what, guys? Metalloid means semi-metal. And who is semi-metal? Usually is your group 14. So group 14, this is the only one, silicon. So we say that something like this, metalloid is silicon. State one use of silicon in the industry. So as we mentioned, silicon used for microchips, used for many different situations. I'll say microchips is one of the easiest answer lah. Diodes, transistors, okay, microchips, all the electronics contains silicon. So then you're gonna go with one of the electronics lah. Okay, and then going down, you see, guys, remember when we learned period 3, right? We learned about oxides, kind of. We got different oxide. Okay, so you got magnesium oxide, aluminum oxide, silicon oxide. Okay, but then you see, magnesium oxide dissolve in acid, but no change in alkaline because hydroxide is alkaline. Just in case you all forgot, hydroxide is alkaline, alkaline. So you see, guys, magnesium no change in alkaline, but dissolve in acid. So let me ask you one thing: what is the properties of magnesium oxide? So I told you, reaction always is opposite one. Okay, means acid alkaline got reaction, acid no reaction, alkaline no reaction. So you see, with alkaline no reaction so I will say magnesium more likely is alkaline. Then silicon terbalik, you see the silicon 4 oxide is reaction with alkaline but no reaction with acid. So I will say silicon is your acid. While aluminium is both sides got reaction. Aluminium like 2 also got reaction. So usually I have a specific term for this. We call it the M4 ferric oxide. But this alkaline, usually we don't call it alkaline oxide. We call it basic oxide. M4 ferric oxide and acidic oxide. Okay, can so this will be your conclusion. So magnesium oxide is a basic oxide, aluminum oxide is an amphoteric oxide, silicon 4 oxide is an acidic oxide. So this will be the stuff that I see from here. Okay, then the equation, guys, this one more on memorize lah. This chemical equation usually I will say very low chance. Okay, equation for oxide will be very low chance. But because why is it very low chance? Like let me show you the answer. It's very complicated one. So if you have the time, you can go and memorize lah. But I would suggest don't go for it. Okay, don't waste your time. Score on other part. Okay, score on other part. Very low chance for this. So okay, my suggestion is this part you selectively ignore. Okay, you ignore for better future. Ignore for better mental health. Okay, so this one you can just let it go. Let this part go because very low chance in writing equation for your oxide part. Okay, but what they really like to ask in oxide is this one. They ask you who is basic, who is amphoteric, and who is acidic. Okay, they might not even give you the term. You must know the term by yourself, like basic oxide, amphoteric oxide, acidic oxide. So all this is the term that you have to know by yourself lah. Okay, so after all this, then we can go for chapter 5. So chapter 5, guys, how many bonds we have? Chapter 5 got ionic bond, covalent bond, hydrogen bond, dative bond, metallic bond. Okay, so in total like 5 bonds at least. Okay, so what we say from here, we have W, X1, and Z. Which element has stable electron arrangement? Explain your answer. So stable is what? We check out. This is 1, this is 2, this is 2.4, this is 2.6. So who got stable? I will say it's X lah. Why? Because it's the only one that is achieved stable. Because it's 2, right? First shell 2 stable is called duplet. So we're gonna say, okay, your X. Explain your answer. Why got no explanation? We can say that element X has achieved stable duplet electron arrangement. Don't know why my explanation disappeared, but then I just add it in. Then they say element Y reacts with Z to form a compound A through sharing electron. Okay, then what is the chemical formula of A? So first of all, we have now Y and Z trying to combine, right? We have Y and then we have Z. So Y is 2.4, Z is 2.6. Guys, how do I know how many Y and how many Z to combine so that Y and Z stable at the same time? Okay. So I told you guys, even though it's not an ionic compound for here, it's a covalent sharing. So even though it's sharing, so for ionic, ionic usually we say like, oh, it's Al or 3 plus, and then O is 2 minus. We can exchange the charge, become Al2O3. That's how we found out the element, the chemical formula for the ionic compound, right? But covalent compound cannot do this because covalent compound don't have positive and don't have negative. So the only thing we can do is to ask yourself, how many more for your Y and Z to become stable? So for Y, you need 4 more. For Z, you need 2 more because 4 and 6, okay, you need 4 more to become 8. 6, you need 2 more to become 8. Right now. So with this, I can exchange my number, become Y2, Z4. So 2 and 4, simplify, becomes YZ2. So I need to draw, if later on we need to draw, you have to draw one Y and two Z. Okay, so YZ2. And state the type of chemical bond, guys. Sharing is what bond? Sharing is considered covalent bond. And what is the type of particles, guys? Remember, type of particle, not solid, liquid, gas. This one also very common mistake in exam. Type of particle, not solid, not liquid, not gas. Okay, it's actually your AIM. What is AIM? You aim for A plus. No, okay? A is atom, I is ion, M is molecule. So for here, guys, sharing no charge, but more than one atom. So obviously it's a molecule. Okay, no charge, but more than one. So molecule lah. And then draw the Lewis structure for A. Okay, guys, Lewis structure makes your life so much easier. Why? Because you don't have to draw circle, circle, circle. Just draw the symbol in the middle and you draw the last shell electron. Okay, you only need to draw which one? Draw the 4 and 6. Okay, so means I need to draw Y and Z too, right? So I'll be having a Y in the middle. Okay, Z on the side. Okay, but like this is here, I draw like this Z on the side. Okay, so how do I draw Lewis structure? You draw the 4 for Y. So, but then if you remember, I told you, how do I decide how many electrons to use for sharing, how many electrons to not use for sharing? It depends on the how many more also. So if Y is 2.4, he need 4 more to become stable. He will contribute all his 4 for sharing. So therefore, I'll put like sorry guys, got some mosquito flying around. So you see, I will put like 2 dots on the left, 2 dots on the right. Then for Z, Z got 6, right? But then he only need 2 more. So means among the 6, he will put 2 for sharing, but 4 more not sharing. So same thing for the other Z. 2 for sharing, 4 not sharing. So this is your Lewis structure. Okay, so guys, so this part is sharing. This is the part that is sharing. Okay, so Lewis structure much easier to draw. No need to draw many circles. Okay, then element W can also share electrons with element Z to form a new compound B. Okay, so W and Z. Okay, what's W? W is 1. Z is 2.6. Okay, guys, it's still a covalent. Why? Because it's actually a non-metal with another non-metal, right? Okay. Some of you might ask, teacher, why one non-metal? I thought group 1 is metal. Yes, guys, group 1 is metal, but not the first element. Because who's the first element? Your hydrogen. So hydrogen is not a metal. So it's a non-metal. So okay, so you see, so W is 1, Z is 2.6. So this one need 1 more to become stable. This one need 2 more to become stable. So you can exchange the number, you get W2Z, which is the same as what they gave us. See, our analysis helps us a lot, right? To double check, oh, my concept is correct. So I exchange the 1 more, exchange the 2 more, I get WZ, W2Z. So draw this arrangement. So to draw W2Z, who's in the middle? Z in the middle, W on the left and right. So I'll be having a Z in the middle. So Z, see, I will draw a big circle first to share with my W, share with my W, this, okay, but W, this is the nucleus, this is nucleus, this is nucleus. Okay, W only got 1 electron, so he'll be using it in the sharing, Z got 2.6, so Z is 2.6. Okay, how he decide his 6? 2 for sharing, not then got remaining 4 not for sharing. So he'll put 2 dots inside sharing, 1 on the left, 1 on the right, and then got 4 dots outside not for sharing. So double check your answer. Is it 8? 2, 4, 6, 8. So your Z is stable. Then for each W, do you see it's 2? W is 2, duplet. Then this is your answer for W2Z. Okay, this one covalent. Okay, so when this question is covalent, but the title right ionic. Guys, sorry, I didn't see the question and the topic carefully. I'm so sorry. But this one covalent, guys. This question is covalent. Okay, compound A and B has the same type of particle, but melting point, boiling point is much higher compared to compound A. Okay, why say so, guys? Do you see? A is covalent, B is also covalent, but the problem is why B got higher melting point and boiling point? So, guys, as you talk about covalent, Covalent compound usually have low melting boiling point because they got what? They got weak van der Waals, right? So think deeply about it. Covalent, is it only got van der Waals? Like covalent compound, is it only got van der Waals? There is another possibility. What is the other possibility? It might have a chance to form hydrogen bond, and that affects your melting boiling point. So how do we form hydrogen bond? Hydrogen bond definition, if you memorize hydrogen bond, is where you have a hydrogen bond to NOF, either one, then he is able to form a hydrogen bond to another NOF in another molecule. So technically, the first requirement is, you check, do you have the requirement to form hydrogen bond? Do you have H bond to NOF? Guys, if you check your periodic table, one is, if you have one electron, one proton, is hydrogen, right? Then you check 2.6, guys. You go and check 2.6. It's actually oxygen. Yeah, so do you see he got H and O? That gives you the first rules, the first requirement to form a hydrogen bond. Okay, so that's why we can see from here. Okay, so it's in molecule B are attracted by strong hydrogen bonds and weak van der Waals force of attraction, while A only got weak van der Waals attraction. Guys, wait, my cat destroying my stuff. I brought the the king of my house. Hi, Mochi. Mochi, say hi. Okay, so guys, you see, so at here, right? Do you see he suddenly come out hydrogen bond, like covalent halfway? Then suddenly ask about hydrogen. Because hydrogen, to form hydrogen, the first requirement is you must have a covalent between H and O. Then only there is a chance to form hydrogen with other NOF. So that's why from here we say B got higher melting point, boiling point, because B is the one that got H bond to O. So you need more heat energy to break hydrogen and overcome the van der Waals. While you need lesser heat to just overcome the force of attraction between molecule A. Okay, so guys, you see, suddenly link from covalent to hydrogen, because yes, hydrogen bond, you need covalent bond. Okay, hydrogen bond, you need covalent. Okay, guys, so this one covalent bond and link a bit to hydrogen bond. Okay, so hopefully you all can adapt to question in this, like this in exam, right? Okay, then going down, this one is another bond. Let me not follow this one. Okay, we just go with this. You see, we have PQRST, and then what we see here is which element can form metallic bond. Guys, how do you get metallic bond? From the word metallic bond, means you must have only metal. So let's find out what's the arrangement. So this is 1, 2.4, 2.8.1, 2.8.7, 2.8.8. Okay, guys, seems like who's the only metal we see here? Group. So who is usually metal? Metal is usually group 1, 2, and 13. So group 1, 2, 13, which one? I would say R. R is suitable one. Then they say P react with Q. What type of bond we form? Okay, so P is what? P is this one. So it's hydrogen, non-metal. And then with Q is this one. So again, group 14 is a non-metal. So what type of bond between non-metal and non-metal will be covalent bond. Okay, so how do we draw? Okay, guys, before you draw, identify the chemical formula first. So P, as we know just now, P is 1, Q is 2.4. Guys, as I said, always ask yourself how many more. So this one P need 1 more. Why P only need 1 more? Because he need 1 more to become duplet. Then Q need 4 more to become octet. So exchange number P4Q. P4Q. Guys, you need to draw 1Q in the middle, and 4P on the up, down, left, right. So you're gonna get something like this. Okay, so I'm not gonna stay too long on this because you're gonna try to do it yourself later on Okay, just to discuss how we can get into this part. This predict whether the compound form can conduct electricity. Guys, can a covalent compound without any positive or negative conduct electricity? Cannot. So we say cannot because from here we say only consists of neutral molecule, or you can say no free moving ion, no ion. Then cannot. Guys, my cat trying to run away. I'm trying to hold him. Even though he looks very cute, but he actually very naughty. Huh? Mochi? Mochi learn chemistry again? Look at his face. Damn angry. Angry face. He Mochi be like, let me go. Let me go. Okay, then going down. Element R is burned vigorously in gas. What type of particle of compound form in the reaction? What's R again? Let's see. R is your 2.8.1. 2.8.1 is actually your metal. Okay, then you burn with gas So basically, metal with non-metal. So we're gonna actually form ion. Okay, guys, because metal, non-metal is ionic bond. So if ionic bond, the compound particles form is ion. Okay, but write the formula of the compound. So guys, as even though we know R can be maybe can be lithium, can be sodium. Even if you check the table, you know it's sodium. But don't write sodium, don't write Na, write R. Okay. So R plus oxygen. Okay, what do you form? Okay, do you realize? Do you see I say I plus O2. I don't just plus O. Why? Because oxygen is a non-metal. It's supposed to be diatomic. Then you're gonna form R2O. Why R2O? Why not RO2? Because R will be positive charge, O is 2 negative charge. So exchange number, you get R2O. So that's why the formula of the compound form is RS. Why RS? Huh? Okay, wait, guys. They say burn vigorously in gas. Did they say gas S? Wait, let me check. Is there any typo here? Guys, do you guys have a gas S right here? I don't know. I don't know. Is it my question error? If they put gas S, then yes, the answer is RS lah. But if they say just burn vigorously in gas, then will be the R2O. Okay lah, but never mind, guys. Let me give you both answer lah. If got S, then it's RS. If no S, then it's R2O. Okay, because it's possible to burn R in oxygen and also in chlorine. Both of that, burning in both of these is possible. But why R give you RS? Because when you burn with S, right? S is what? Do you see S is group 17? It's chlorine, right? So if you burn with chlorine, it will be just a negative charge. So it'll be R plus S negative, then you just get RS. But if you burn with oxygen, you get R2O. Guys, know how to adapt the question, Can I burn with R and chlorine will be RS, or if you burn with O will be R2O. Okay. State two differences of physical property between B and C. So B is what? B is covalent, C is ionic. Okay, guys. Compare covalent ionic in terms of physical property. Melting point, boiling point, electrical conductivity, all these can be answered. You see. So compound B is this one say low melting boiling point, but for C is high melting point. So because low melting point is what? Covalent. High melting point is ionic. Oh, guys, my mouth full of mochi's fur. Hey, your fur dropping very seriously, mochi. Okay, then of course, we also say covalent insoluble in water, but ionic soluble in water. Because ionic got charge, so got charge, then can soluble in water. Okay, and then explain why T exists as monoatomic. Guys, you see T, Do you see 2.8.8? It has achieved what? Achieved stable, octet electron arrangement. He does not need to share, lose, or gain electron to become stable. So we can say that from here. Has achieved stable octet electron arrangement. Okay, guys, hopefully your group 1, group 17, your covalent bond, your ionic bond, okay, all this is quite familiar already, huh? Wow, full of whisper. Okay, and moving on, got some bonds that are lower chance. Okay, we are like your hydrogen bond lah. So guys, going down, you see next one. They say which compound can form hydrogen bond between molecules? Guys, hydrogen bond must have what? H bond to NOF. So I will say H bond to NOF, this one possible. N H bond to N O F, this one. Okay, H bond to F. This one. Okay, so this four is possible lah, because of H bond to F NOF. Okay, so you see the four answer came out. Then which one can you form hydrogen bond with water? So we can say the rest of the three lah. Okay, and then after hydrogen bond, they also ask you to which one can form dative bond. Because what's dative bond? Dative bond is also sharing, just like covalent, but covalent is a very fair sharing where one I share you one, you share me one. Dative bond is what? Dative bond is you have a H plus that will share with a guy that don't have any electron at all. So of course, from here, okay, guys, this one, if you remember the thing I mentioned in class, the answer here is actually the this few. Dative bond got HBF3 BCl3. So usually what kind of people like to form dative bond with ammonia is with the H plus, this one got H plus, and then this is BF3, which is a B3 plus. Hey, all the fur flying around. Okay, so guys, dative bond, if you remember, is like this. Like you see ammonia is like NH3. Okay, then what he do is he'll bond with the H plus, and then he will form like this. So NH3, and then you will form H with a plus. This one is dative bond, where he share electron. He got because your nitrogen he got lone pair. So this lone pair he's willing to like share unconditionally to your H plus, then they form this dative bond. Okay, so you see like covalent bond usually is a straight line so dative bond is an arrow. So this one something extra repellent. Okay, then got methane, CH4, methanolic acid, a new weird name here. So they are both covalent, but which one is soluble in water? So guys, if you want soluble in water, means you need to have a hydrogen bond. But how you get hydrogen bond? Must have H and O. So this methane don't have H and O, only got H. So I will say methanolic acid is soluble in water. Why? Because it has the COH group that can form hydrogen bond with water. Some extra question lah. But guys, I will say this hydrogen bond very low chance in exam lah. So just go through as your last part in your revision. Okay, you revise other part first. Only you come for the hydrogen bond, dative bond, and stuff, because all these questions at the back usually is like rare question. Okay, unless your teacher wants you to die. If not, usually teacher just like 2 marks or maybe 1 mark, 2 mark like that. And then in terms of chemical bonding, explain why zinc is an electrical conductor. So guys, zinc is just what? Zinc is just a metal, right? So what is the bonding in metal? We have metallic bond. And how metallic bond conduct electricity? Just now guys, remember ionic bond? Ionic compound, ionic bond, they conduct electricity by free moving ion. But if it's a metallic bond, they don't use free moving ion. They have free moving what? Free moving electrons. Remember we learned the delocalized electrons? This is where the word comes in. So zinc is a metal with metallic bonds where it contains delocalized electron that can move when there is a potential difference, basically electricity lah. They can carry your electrical energy. Okay, and what is hydrogen bond, guys? Definition of hydrogen bond. You must have a hydrogen, is a type of attraction force where a hydrogen bond to a strongly electronegative atom, such as NOF, the fluorine, oxygen, not nitrogen, then with another electronegative atom, which is your fluorine, oxygen, and nitrogen, in another molecule. So this will be the full definition for hydrogen bond. You must have a H covalent bond with NOF first, then only he can form a hydrogen bond with NOF from another molecule. So this will be a full definition for hydrogen bond. Okay, and this is the reason why HF got higher boiling point than HCl. Because do you see HF is fluorine, but HCl is not under here, right? Cl, chlorine, is not under your strong electronegative atom. Okay, so we can see from here. So molecules of HCl are attracted by weak van der Waals attraction force. So less heat energy required to overcome the weak van der Waals. While for HF, got van der Waals and hydrogen. Got one more. He also got weak van der Waals, but got one more hydrogen bond. So more heat energy is needed to overcome the weak van der Waals and break the hydrogen bond. Same, guys. I show you this type of question, this explanation very many times already. So hopefully, if this didn't really come out in exam, don't give up, okay? And then usually covalent compound cannot dissolve in water, but suddenly your alcohol can. Why? Because usually covalent compound, they don't have any charge to dissolve in water, but your OH appears to form a hydrogen bond to your water. So we can see from here, ethanol consists of oxygen, which is very electronegative. Then he can form hydrogen bond in water molecule. Okay, form hydrogen bond in water molecule. Okay, so hopefully, guys, all this you all later on you all try to write it again. I just discuss on how you go through. Okay, how you get all this point. Okay, then last question. You see, ammonia is a covalent compound. It dissolves in water and produces a color solution. Right? Okay, this one involve a little bit on okay lah, can lah. Okay, see, so ammonia, guess how it goes, So he goes with ammonia is what? Ammonia is NH3. And then he dissolves in water, is H2O. So what is inside H2O? Got H plus and OH minus. So this combines. Okay, when this combine become what? Eventually becomes NH4 plus. So we call this the ammonium ion. Okay, so the NH3, take the H plus, becomes NH4 plus. And then your OH minus is formed at the back. And explain how ammonia gas is soluble in water. So guys, first of all, ammonia gas usually is covalent compound. But covalent compound usually don't soluble in water. That's why suddenly ammonia soluble in water. So it will be the hydrogen bond again. You see, ammonia consists of hydrogen that forms covalent compound with N. Which is N is a high electronegativity, just like H and O. Now you got H and N. So therefore, you can form a hydrogen bond with the water molecule. So ammonia got hydrogen bond with water molecule, and then this makes them soluble. So you see, so formation of hydrogen bond, okay, make it soluble in water. Okay, this is a quick go through, guys. It's just to tell you that this is just the appearance of hydrogen bond. Okay, going down, and then based on your answer in B1, draw a Lewis structure involving a dative bond and label dative bond. So I actually draw the diagram just now. So dative bond will be something like this lah. See, dative bond. Okay, NH3 with a dative bond. Okay, guys, this one not very nice. Okay, you all draw the one I have just now. So this one N H H H arrow H with a bracket plus, and then you can label this as dative bond. Okay, draw the straight line and arrow lah. This one slightly easier, okay, much more clear to understand. Okay, and explain how dative bond is formed. Guys, as I mentioned, what's the definition for dative? It's also sharing, but the sharing only come from one atom. Means one side not contributing, the other side is contributing. But why your dative bond is able to form, like why N is okay? Because you got lone pair. Your N got lone pair. So you can say hydrogen ion does not have any electron in the shell. Then the nitrogen in ammonia got lone pair of electron. Then they can form dative bond. They must fulfill the requirement, like one guy is having no money at all, okay, and then one guy is very rich, then he willing to like share to him. Okay, so that's the definition for dative bond. That's a requirement for dative bond. And finally, copper metal is used in making electrical wires because it is a good conductor of electricity and has high melting point, relate the metallic properties of copper, and in the above statement to the metallic bond. Okay, so when we talk about metallic bond, guys, what do we understand about metallic bond? Your metal atom, they will lose their electron, but the electron, no one gain. So if no one gain electron, you have C of delocalized, means that you have like homeless electron that have no one own it. So this free moving delocalized electron, they are able to like carry your electricity from the negative terminal to the positive terminal and make them a very good electrical conductor. So you can see from here, yeah, so the valence electron of copper metal easily donated and delocalized in solid state. But who do you have anyone who gain electron? No, so we only have positively charged metal ions are formed, okay, and they are able to move freely, okay, to form an electron sea. So with this, they actually have electrostatic attraction between the sea of electron and the positively charged metal copper metal ions, and these electrons can move freely and carry charges from negative terminal to the positive terminal and conduct electricity. So guys, I know a lot of things to memorize. Okay, I know a lot of things to memorize, but as I said, guys, focus on the front chapter first. Chapter 2, chapter 3, chapter 4, chapter 5, ionic covalent. The dative, the hydrogen bond, the metallic bond, the bonding at the back not very important. Not very important. Focus on ionic and covalent most importantly. Okay, guys, can so I try my best to go through one set in within 2 hours lah. You see, it's almost 2 hours already. Okay, I non-stop talking. You all maybe non-stop writing, or maybe you all just listening to me and falling asleep. Okay, so of course, guys, hopefully you all try to do your best on the coming exam. Okay, so the rest of the 2 set you try to finish it. If you cannot do, you check the answer. If you check the answer, you cannot understand, then you text me lah. Then I try to explain to you through WhatsApp. Okay. If you finish the 2 sets, confirm can score A in your coming exam. Chapter 2 focus on isotope only. No, chapter 2 still got the heating and cooling curve. Heating, cooling curve, and isotope. Chapter 3 got empirical formula and also the stoichiometric. Stoichiometric, later I attach a link to my YouTube channel. One of my video got teach you stoichiometric. So I don't want to spend stoichiometric in this revision class, because you see, until here already, I almost spent 2 hours. So if I still need to talk about stoichiometric, I need another half an hour. Okay. So you put some effort also lah. I don't know how to do the 3-step mole ratio. That's stoichiometry lah. So I have a video just for that. And that video inside got PDF attached. Okay. So if you really don't know how to do calculation, you just watch that video. Anything don't know, just WhatsApp me. Okay. Can so guys, all the best for your coming exam. Hopefully this last minute class helps you a little bit lah, at least a little bit lah. Then I hope that you all can score better lah. Okay, so guys, after you get a result, let me know. Okay. Okay, see you guys after your exam. Okay, bye guys, bye bye. Bye bye.